Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA 2021, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Circle the answer to 0.02 times 100. Well, if I'm taking 0.02 and I'm timesing it by 100, then what I'm going to be doing is I'm going to be shifting that decimal point 2 jumps to the right, aren't I? So it's going to return 0.02. If I times that by 100, it's going to turn it into 2. So it's that one there. Question 2. Circle the expression that is equal to x plus x plus x minus x plus x. Okay, well, how many plus x's have we got? We've got an x plus another one plus another one plus another one. So we're adding 4 x's together, which gives us 4x. And then if we take one away, that's going to leave us with 3x, isn't it? So it's that one. Question 3. What is 260 millimeters in centimeters? Circle your answer. Well, all you really need to do is look at your ruler, don't you? So I've got like a magical pretendy ruler here, but if you look at your ruler in centimeters, it's going to go 0, 1, 2 along it, and you'll see you've got 10 little divisions in between, and that's because each one of those little divisions is a millimeter. So if you want to convert from millimeters into centimeters, you need to know that 1 centimeter is equivalent to 10 millimeters, just as it is on your ruler. So if I take 260 and I divide it by 10, that's going to leave me with 26. It's equal to 26 centimeters. It's that one there. Question 4. Which shape can have sides with lengths that are all different? Circle your answer. Okay, well, I'm going to do the obvious ones that it isn't first, I think. Now, a rhombus is like a pushed over square, isn't it? So if you get a square and then you push it over, you're going to get a rhombus. Okay, so a rhombus looks like that. Now, because it's a pushed over square, all the sides are going to be the same length, aren't they? Okay, they were all the same length before you pushed it over. They're still all the same length. So with a rhombus, all 4 sides are the same. So they're certainly not all different lengths. So rhombus is right out. Parallelogram. With parallelogram, you have 2 pairs of equal and parallel sides. So this side is parallel to this one. This side is parallel to this one. But also that length is the same as that length, and that length is the same as that one. So a parallelogram has got 2 pairs of equal length sides, so they can't all be different, so it's definitely not a parallelogram. Now with a kite, you've got 2 pairs of adjacent equal sides. Okay, so those top ones are the same and those 2 bottom ones are the same. So again, they're all, well, you've got 2 pairs of the same length, so they can't all be different. Now a trapezium, on the other hand, can be all different. You could have like a long one there, an even longer one there, one like that, and one like that, where all the different sides are a different length. Okay, so trapezium is the one we want. A rule for a trapezium is just has to have one pair of parallel sides, but they don't have to be the same length, and the other two can be anything you want. So yeah, trapezium. Question 5, work out what -5 times 8 is. When you're multiplying two numbers, just kind of go ahead and multiply them first. So 8 times 5, you should know, is 40. And then think about what sign you've got. Now here, we've got a negative number and we're multiplying it by a positive one. Now the fact it's in brackets there, it really isn't making any difference. In fact, those brackets are serving no purpose at all. You could easily just write this without the brackets the same way. Okay, so I've got -8 and I'm timesing it by 5. When you're multiplying a negative with a positive, then your outcome is going to be a negative number. So that is going to be -40. Question 6. Luke buys 4 apples and 5 bananas. The total cost is £3.70. Each apple costs 35p. Work out the cost in pence of each banana. Okay. So I know the total cost of everything. That's going to be the cost of the apples and the bananas together. And I know the cost of each individual apple. I also know the number of apples. So with the number of apples and the cost of apples, I should be able to work out the cost of all 4 apples. And then if I then take that away from the £3.70, I'll be left with the price of the 5 bananas. And then if I divide that by 5, I'll get the price of 1 banana. So that's kind of my plan. So I'm going to start with these two. I'm going to work out how much they cost. I'm going to take it away from that one, and then I'm going to go over there and deal with that. All right, so that's the plan. So what do 4 apples cost first off? Apples cost, I've got 4 apples and they cost 35 pence. And I'm going to write it as 0.35 in pence, okay, because we've got pounds and pence. So I'm just going to do 0.35. If it's easy, you can just think of it as 35p. So times it by 4 is doubling and doubling again. So if I got 35p and I double it, I'm going to get 70p. And if I double it again, I'm going to get £1.40. So that comes to £1.40. Okay, so that's what the apples cost. So next thing, I'm going to look at what the bananas cost. I'm going to take that £1.40 away from 370, and I'm going to see what's left. Okay, so what is £3.70 minus £1.40? I could do that as a column subtraction if it's easier. 370, 140, subtract, that's 0. 7 take away 4 is 3. 3 take away 1 is 2. So that comes to £2.30. So 370 minus 140, that's £2.30. Okay, so that's what was left over after I'd paid for the apples. So then that is going to be the cost of the bananas then, isn't it? Cost of bananas is equal to that. So now I want the cost of 1 banana. Cost of 1 banana. That's going to be my £2.30 divided by the number of bananas. Now there are 5 bananas, so I want to divide £2.30 by 5. So let's just do a quick bus shelter short division. Divisor on the outside, £2.30 on the inside. 5s into 2 don't go, that goes in 0 times. With 2 left over, so I'm going to write the remainder up here. 5s into 23, well, that goes 4 times. 4 5s are 20, so then the remainder is 3. And then finally, 5s into 30 then go 6 times, remainder 0. Okay, so then the cost of 1 banana then is going to be 0.46 pence, or 46p, isn't it? 0.46 pounds or 36 pence. Okay, we've done it. Question 7. Rashid counts the pieces of homework he has done in 3 subjects. He draws a pictogram to show the result. So the key is that circle, which has got like little 4 divisions on it, represents 4 pieces of homework. So if you think about it, each one of these little pieces of pie in here is a single piece of homework then. So the little circly thing is, oh, that was a bit chunky, wasn't it? So that means that we can do things like this down here. So that bit there represents two homeworks, doesn't it? Okay. So Rashid has done 5 pieces of geography homework. Show this information on the pictogram. Okay, so geography is here. So I need to draw a circle with, a little cross inside. That represents 4 pieces. So I've got one more piece to show. So I need to show like a quarter circle for the extra one piece, like that. Okay, so that is 5 pieces of homework. Then part B said Rashid spent 30 minutes on each piece of homework. Work out the total time he spent on homework for these 3 subjects. Give your answer in hours and minutes. Okay, so you spent 30 minutes on each piece of homework. We need to know how many pieces of homework you did altogether so we can work out the total time. So let's go back to the pictogram and count how many bits of homework we had. Now in the maths row, we've got 1, 2, 3, 4, 5 little circles. Now each one of those circles represents 4 pieces of homework. So 5 times 4, that's 20, isn't it? So he must have done 20 pieces of maths homework. I'm liking that he did most maths homework. That's great. Right, now next one along, I've got 3 full circles. So 3 times 4 is 12. Plus I got those 2 extra little ones in half a circle. That's going to be another 2, isn't it? So that's going to be 14 altogether. And then we worked out already that we needed 5 geography homeworks. We already drew those. Okay, so altogether, how much homework is that? 20 plus 14 is 34. Plus 5, that's 39, isn't it? That comes to 39. So it's got 39 pieces of homework. Now each one is 30 minutes. Now you can think of 30 minutes as half an hour, can't you? So he can do 2 bits of homework in an hour. So if I divide 39 by 2, it should tell me how many hours it took then, shouldn't it? So 39 pieces of homework divided by 2, what's that? Well, if it was 40 and I divide it by 2, I'd get 20. So if it's 39 divided by 2, I'm going to get 19.5, aren't I? Okay. Now, if you're struggling to do that in your head like I did it, you could do another bus stop division. So 2's into 39, 2's into 3 go once, remainder 1. 2's into 19 go 19 times, remainder 1. Now I haven't got any 1 to put it with, so I'm going to have to put an extra 0 in there, carry over the 1 to that one. The decimal points goes there, 2's into 10 go 5. You can see it comes to 19.5. Okay, so anyway, it comes to 19.5, and that's going to be the number of hours. Now it does say it wants it in hours and minutes though, down here. So 19.5 hours is 19.5 hours, and half an hour is 30 minutes. So I'm going to just round off by saying that that is 19 hours and 30 minutes. Question A, a travel company is taking some passengers on a trip. They can use coaches or minibuses. Each coach can carry 53 passengers. Each minibus can carry 12 passengers. The passengers going on the trip would exactly fill 3 coaches. If the company uses only minibuses, how many will they need? Okay, so we've got a coach. A coach carries 53 passengers, and we've got 3 of them. Okay, we can exactly fill 3 coaches, so that means we've got 3 lots of 53 passengers, haven't we? Okay, so then total passengers, that's going to be 3 lots of 53, isn't it? Okay, 3 50s is 150, 3 3s are 9, so that is 159 passengers. Okay, now minibuses can carry 12 passengers. 12 into 159, seem to be doing heaps of division at the moment. 12's into 159, 12 into 1 doesn't go, 12 into 15 goes once, remainder 3. 12's into 39 go 3 times, and that's remainder 3. But I haven't got any number to put it with, so I need to add an extra 0 so that I can then put the 3 next to it. And then 12's into 30, that goes 2 times, remainder sum. But already I can see what the answer is. I don't really need to do any more than that. I can see that it's 13 and a bit coaches, but you can't have a part coach, a minibus, sorry. So you're going to have 14 minibuses. Okay, so I'm going to say number of minibuses That's equal to 159 divided by 12, which we said was 13.2. And so I know that I need 14 minibuses then, because I can't have 13 because those extra passengers are not going to fit inside. Okay, so 14 minibuses are required. Question 9. One side of a triangle is extended. Circle the sides of angle X. Okay, so we know two angles in a triangle, and we should know that all three of those angles, so that one up there altogether, is going to add up to 180 degrees, aren't they? Okay, so I know that angles in a triangle sum to 180 degrees. So I'm going to call that one, let's call it Y. I don't know what it is yet, let's just call it Y. So 40 plus 60 plus Y is going to be 180 then, isn't it? So 40 plus 60 together, those two added up is 100. Okay, so if I then subtract 100 from both sides, they cancel, leave me with Y on the left, and on the right I'm going to have 180 take away 100, which leaves me with 80 degrees. So that means that one in there, look, is 80. Okay, and I know that Y and X form a straight line, and I know that angles on a straight line sum to 180 as well. Okay, so Y plus X is 180, and I know that Y is 80, so 80 plus X is 180. So then taking 80 away from both sides, I'm going to get X is 100 degrees, which is that one there. Now, all of this written stuff here you don't need to write down for this. It's just a 1 mark question. You just need to circle it, you'll get the mark. Just bear in mind though that some questions do want you to write these sort of things down, so you do need to know these angle rules and be able to write them down like I have there. But not required in this question, but just for thoroughness I thought I'd write them down for you. Okay, let's move on. Question 10. Pavel uses his calculator to work out 352 times 7,268. Circle the last digit in the answer. Now, to work out the last digit, you don't have to do the whole calculation. I'm just going to show you quickly it as column multiplication, just to make it easier to see. 352. Now, if you think about it, I'm going to multiply the 8 times the 2, and then the 6 times the 2, and then the 2 times the 2, and then the 7 times the 2. So I'm just going to do the first one for now. 8 times 2 is 16. So I'm going to carry 1. And then I'm gonna multiply the 6 and the 2, and I'm going to write the answer here. And the 2 and 2, I'm going to write the answer here. 7 and the 2, I'm going to write the answer here. And then what I'm going to do is I'm going to add an extra 0, and I'm going to start multiplying the 8 and the 5 and write the answer here, and the 6 and the 5 and write the answer here, and the 2 and the 5 and write the answer here, and the 7 and the 5 and write the answer here. And then what I'm going to do is I'm going to add 2 zeros, and I'm going to do the 8 times the 3, I'm going to write the answer here, and so on, yeah? You get the idea. And then what we're going to do then is we're going to add all these numbers up to get our answer. But we're only interested here in the last digit, and the last digit is here. And I already knew what the last digit was in the very first step, because I'm adding the first thing I worked out plus 2 zeros. So it's just going to give me 6, isn't it? And I knew that already when I multiplied these two numbers together, the 8 times the 6. The 8 times the 2, that gave me 16. So I knew already that that first digit is a 6. So when you're looking at these two numbers and you're thinking, well, how do I know what the last digit is going to be? Do I have to do the whole thing? No, you don't. You just need to look at that digit and multiply them together. In this case, you get 16. And then so that very last digit on the end is the one you want. It's going to be a 6. Question 11, complete the diagram so that it has rotational symmetry of order 4, center of rotation at point A. Okay, so what I would suggest you do in a question like this is put your hand up and ask the invigilator for a sheet of tracing paper. Then trace your shape on the tracing paper. I recommend putting a little cross in the center of rotation to help you know when you've kind of turned 90, 180, 273, 60 degrees. and then stick your pen on A and turn it 90 degrees, and you'll see that when your cross lines up again, your triangle is going to be over here. So I'm just going to put the corners in. Corner goes here, corner goes here. Let's join that up. Okay, and then we're going to continue. We're going to rotate the tracing paper around another 90 degrees and stop, and then we can see where our triangle lies now. You can see we've got a corner here and a corner here. So let's just add that in. Okay, and finally we're going to get the tracing paper back again, and we're going to go one more turn, and then you can see that I'm going to end up with a point here and a point here. Okay, so again, finally just going to join those up. And then that is our little shape with rotational symmetry order 4. So now if you trace the whole thing, you can see that in a full turn it will look the same in exactly 4 places. Question 12, 10% of 2,100 is 210. Work out what 43% of 2,100 is. Okay, so they've partially done like a percentage thing for us. 2,100 is equivalent to 100%, and we know now that 10% is 210 because they told us. Now what would 1% be? 1% would be that divided by 10, that would be 21. Then to make 43%, then I'm going to use 4 of those, 4 10%, and 3 of those, 3 1%. 4 10s and 3 1s together make 43%. Now if I do the same thing on the other side, if I use 4 of those and 3 of those, what do I get? So 4 lots of 210 first. 4 lots of 200 is 800. 4 lots of 10 is 40. So that's going to be 840. And then 3 lots of 21. 3 lots of 20 is 60. 3 lots of 3 is 3. So together that makes 63. Just quickly total that up. 0 and 3 is 3. 4 and 6 is 0. Carry 1. Then that's going to be 903. So 43% is going to be 903. Question 13. Katie records the number of cars using a drive-through each hour for 24 hours. And here are the results. Katie makes this tally and frequency chart to put the data into groups. And then, so I've got like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. I've got my place to put my tally marks, and then I've got a place to work out the frequency. Make 2 criticisms of Katie's tally and frequency chart. You do not need to complete the chart, so don't sit there and fill it out because that would be long, and you don't want to be doing that. Right, so what are my criticisms? Now, first off, my criticism is my groups. They overlap. Okay, what am I going to put the number 10? Am I going to put it in 0 to 10, or am I going to put it in 10 to 20? Okay, so that's my first criticism. I'm going to say the groups overlap. Okay, so 10 is in 0 to 10 and in 10 to 20. Okay, so and so on. So that's an example, for example, e.g. 10 is in 0 to 10 and 10 to 20. Okay, so that's my first one, the groups overlap. Now, what's my second criticism? Is there a place for everything? Just scanning through my numbers, I can see there isn't. So if you look here, look, there's a 53 here. Where's that going to go? There's no space for it because my tally chart only goes up to 50. So that one hasn't got anywhere to put it. Okay, so I'm going to say not all values can be placed in the tally chart, e.g. 53. Okay, that's it. So don't sit there and do the chart. Make sure you read the blurb, especially if it's in bold, because that normally means students forget to do it. Okay, anything in bold, you have to really be careful and double check that you read. But just generally, make sure you read all the question before you start it. Otherwise, you could spend, a good 5 minutes filling out that tally chart and then realize you don't even need to do it. Right, let's go. Question 14. Counters in the bag are red, white, or blue. A counter is picked at random. Complete the table. Okay. Now, all the counters in the bag are red, white, and blue. So when you pick a counter out, it's going to have to be red or white or blue. There's no other options. Okay. So that means that you are certain to pull out a red or white or blue, which means that the three probabilities of red and of white and of blue need to add up to 1, because 1 is the mathematical value of certainty. So I'm going to call the probability of getting blue there x. Then because of completion, it's kind of what we call the rule of completion with probability, that when you take the probabilities of all of the different outcomes and you add it together, it's going to have to be 1, because you are certain to get one of those three outcomes. Okay, so let's add together what the numbers I know, 0.15 and 0.4. That adds up to 0.55, doesn't it? So 0.55 plus x is equal to 1. So then taking 0.55 away from both sides, what's 1 take away 0.55? It is 0.45, isn't it? Okay, so that's 0.45. So x is 0.45, 0.45. Let's just write it in there. Question 15. Here is a calculation. 31 times 84 is 2,604. You can use the calculation to help answer the following questions. Okay, so if 31 times 84 is 2,604, if 31 times 84 is equal to 2,604, so then if I divide both sides by 84, should see that that cancels with that, and then it shows me that 2,604 divided by 84 must be equal to 31 then. Okay, so the answer to that is 31. Now if I want to work out what 3.1 times 8.4 is, I know that 31 times 84 is 2,604. Now 3.1 is a power of 10 less than 31, isn't it? Okay, so my answer is going to be a power of 10 less. Okay, but also 8.4 is a power of 10 less than 84. So my answer is going to be 2 powers of 10 less than 2,604 then. So dividing 2,604 by 10, I'm going to get like 260.4, and then dividing it by another 10, I'm going to get 26.04. So that's my answer then, 26.04. Hope that makes sense. Part C says work out 31 times 85. Now I know that 31 times 84 is 2,604. So 31 times 85, if you think about it, that's one more 831, isn't it? So, if I just add on 2,604, if I add on another 31, it's going to be 5, that's going to be 3, 6, 2, 2,635. That should come to 2,635, because it's kind of like the next number in the times table, isn't it? So you just add on another 31, you'll get it, 2,635. Question 16, a password has 30 characters. It is made up of 50 numbers, 15 letters, and some symbols. Work out the ratio of numbers to letters to symbols. Give your answer in its simplest form. So numbers to letters to symbols. So how many numbers we got? We got 5. How many letters we got? We got 15. How many symbols we got? Some symbols. Okay. But we know it adds up to 30, and I know that 5 and 15 together make 20. So symbols have got to be the rest then, isn't it? So 20 taken away from 30 gives me 10. The number of symbols is going to be 10. Okay, so I've got the ratio of 5 to 15 to 10. Now notice they're all multiples of 5, aren't they? So if I divide them all by 5, I'm going to get 5 divided by 5 is 1, 15 divided by 5 is 3, and 10 divided by 5 is 2. So then the ratio is 1 to 3 to 2. Question 17, work out 5 6 plus 7 twelfths. Well, 5 6 plus 7 twelfths. When we're adding fractions, we need to have the same denominator, don't we? And we don't. We've got 6 and 12. But we can easily turn a fraction in sixths into a fraction in twelfths by multiplying top and bottom by 2. Because 6 times 2 is 12. So doing that, 5 times 2 is 10. 6 times 2 is 12. So 5 6 is the same thing as 10 twelfths. 7 twelfths I don't need to do anything with because it's already in twelfths. And then when you've got two numbers with the same denominator, then you just go ahead and add the numerators, don't you? So 10 plus 7 is 17 over, and the denominator stays the same, just stays as a 12. Okay, so the 12 stays the same, the denominator stays the same, the numerators we add together. Okay, so I've got 17 over 12. Now it says here that it wants it as a mixed number. Now a mixed number is a number that's made up of a whole number part and a fractional part. So in order to turn a top-heavy fraction or improper fraction into a mixed number, you need to actually do the division. You have to say, well, how many times does 12 go into 17? 12 goes into 17 once. So that's where the 1 comes from in the mixed number. And what's the remainder? You have to kind of do it like you did in primary. 17 divided by 12 is 1 remainder. Well, there's 5 remainder, isn't there? So, and the remainder becomes the numerator of your fraction, and the denominator just stays as the denominator. Okay, so 12 goes into 17 once, remainder 5. That tells me that 17 over 12 is 1 and 5 twelfths. Question 18. The cost of making a phone call is a fixed charge and a cost per minute. The cost of phone calls up to 5 minutes are represented by the graph. We've got cost of pence down the left-hand side and the length of call along the bottom. Write down the fixed charge. Okay, well you can see for a call of length 0 minutes, you're already paying 20p there, aren't you? So that is going to be the fixed charge. Okay, so even for like a 0 length minute, 0 length call, you're going to charge 20p. Work out the charge per minute. Well, if you have a look between 0 and 1 minute, then you can see that for every 1 minute we go along, we've gone up by 4 little squares, which on this scale, if from 20 to 30 is 10 and we're going 4/5 of that, that's going to be 8, isn't it? That's going to be 8 pence. Okay, so work out the charge per minute. That's going to be 8p. So work out the cost of a phone call lasting 7 minutes. Okay, so the cost is going to be the 20p standing charge plus the 8 lots of the number of minutes then, isn't it? So if I let m be equal to the number of minutes, then the call costs 20p plus 8p per minute. So now I know the number of minutes is 7, then the cost is going to be 20 plus 8 lots of 7. So 8 lots of 7 is 56. And 56 plus 20 then is 76p. Okay, so the cost of phone call lasting 7 minutes is going to be 76p. Question 19. A company sells bags of toffees and bags of mints. Here is the number of sweets in 11 bags of toffees. So you can see there's some variation from bag to bag. One's got 55 in, one's got 50, next has got 49, and so on. And here are the number of sweets in 10 bags of mints. And you can see again, the bags vary from bag to bag. The company claimed that the average number of sweets per bag is at least 50. Using medians, is the company's claim correct for each type of sweet? You must work out the median for toffees and the median for mints. Okay, now for medians is the middle value, but only after you've ranked them from smallest to biggest. Okay, so before you can do medians, you're going to have to rank them. Now, just scanning through the values for toffees there, I can see that the smallest value is 47. Okay, so that's the one I'm going to start with on the left. Okay, Then I've got some 49s, 49 and 49. So I'm going to write those next. So 49 and 49. Right, what's next? Have I got any 50s? Yep, I got one there, look, 50. So that comes next. What about 51s? Oh no, I've got another 50. Another 50 there. Ooh, almost missed that one. 50. Is that all the 50s? Yep, I've got a 51 though. 51. Any more 51s? Nope, just one of those. 51. What's next then? I've got a 54 next. 54. And then I've got a whole bunch of 55s. 1, 2, 3 of those. 55, 55, 55, and then 57 on the end. That's everything. Now I wrote the numbers one under each other so I could just check I had the same number after I did it and I hadn't missed any out. Okay, so just kind of writing them underneath the existing numbers just saves me the job of counting them at the end. Okay, so now I've got them ranked from smallest to biggest. How many numbers are there in this data set? There are 11 bags. So what is the middle one? Now the easiest one to find the middle is take your number of items, add 1, and then divide by 2. So 11 plus 1 is 12, and 12 divided by 2 is 6. So it's the 6th bag. So counting in from the either end, 6 jumps. So 1, 2, 3, 4, 5, 6. You can see that the median there is 51. Okay, you can count in from both ends until you meet in the middle as well. That also works. Okay, so that the median of those is 51. Right, then for the mince, okay, I'm going to do the same thing. I'm just going to scan through looking for the smallest one first. Smallest is 46, so that's going to go on the left. Then I've got some 47s. How many of those I've got? 1, 2 of those. So let's write those next. Oh, actually, I'm not going to bother because I've just noticed that these are actually in the right order. So, okay, don't bother. Yeah, they're already in the right order. So all I need to do is find where the median one is. Now this time I've got 10. Now when you've got an even number of things, it's a little bit more complicated to find the median. If you add 1 to 10, you get 11. And 11 divided by 2 is 5.5, isn't it? 5.5. That tells me that the median is kind of halfway between the 5th and the 6th value. So counting through and finding the 5th value, 1, 2, 3, 4, 5, that's the 48. And the 6th value is the 50. So my median then is going to be halfway between those two. So you can either add them together and divide by 2, or you can just work out the span between 48 and 50 is 2. Half that 1 and add it onto one of them, you'll get 49. Either way, the median is 49. Okay, so that's my median for the mince, and my median for the toffees was 51. Right, so I'm just going to say for toffees, median equals 51. So tick the box for toffees, yes. Then there is sufficient evidence that the median number, the average number of sweets in the bag is at least 50. Well, I worked it out and it's 51. So yeah, it kind of works. But with mince, the median is actually only 49. Okay, so you know, can't really say that there are at least 50 of those because on average they've only got 49. Now, if they were smart, they could add them both together and they would probably get a median of both things together over 50. So I don't know, they could probably still claim it if they just said, well, you know, on average each bag has got 50 or more in there, because I think that would work out to be more than 50. But breaking it down like that, definitely mints do not meet the mark. Question 20. Freddie tries to work out 29.15 plus 83.47 divided by 9.82, and he gets the answer 37.65. By rounding each number to the nearest 10, show that his answer is incorrect. Okay, so we're going to estimate this answer by rounding each number off to the nearest 10. So 29.15 to the nearest 10, that's going to be 30. 83.47 to the nearest 10, that's going to be 80, and 9.82 to the nearest 10 is going to be 10. Okay, so then if I add those two things together, 30 plus 80, that is 110, and 110 divided by 10, that is 11. Okay, so we worked out that this number, an estimate of this number is 11. Now he got the answer 37.62, which is 3 times bigger. So we can use our estimate, which is going to be pretty close to the answer, and say, well, his answer is well out. Okay, so if 11 is close to the answer, then 3 times as large is not going to be close to the answer. So we're going to say our estimate is 11. Freddie's calculation, or Freddie's answer, is more than 3 times bigger than this. Therefore, it cannot be correct. Okay, so estimates don't give you spot on what the value is, but they tell you the overall magnitude of the number, how big the number is. Okay, so you know it's going to be around 11. It might be 9, it might be 13, but it isn't going to be 30. Okay, so yeah, he's not correct. Question 21. A straight line passes through 2 parallel lines. Circle the angle that is corresponding to the angle x. Okay, well, corresponding angles are on the same side of the transversal. That's the line crossing them. So they'll be on the same side, and they're going to be on the same side also of the parallel lines. So you can see that x and b are on the same side of the transversal, the green line, and x and b are on the same side as the 2 parallel lines, so it's x and b. So the one that corresponds then is going to be b. Question 22a. Lucy wants to simplify 6a minus 7b minus 2a, and she writes 4a minus 7b. Is she correct? Tick a box. Give a reason. Okay, so is she correct? Now, BidMaths would say do brackets first, but you can't actually subtract a's from b's, so you can't actually simplify what's inside that bracket any more than it already is. So we're gonna have to be a little bit more clever about it. What you've actually got here is 6a minus 1 lot of 7b minus 2a, haven't you? So then taking -1 and timesing it by these 2 numbers to remove the bracket, I should get 6a minus 7b plus 2a. Okay, so then collecting like terms, I've got 6a and 2a. That gives me 8a. It's going to give me 8a minus 7b. Okay, so she is wrong, because it should be 8a minus 7b, not 4a minus 7b. So I'm going to tick no and give my reason. It's going to be a mathematical reason. The answer should be 8a minus 7b. 22b. Lucy also wants to simplify 3p squared times 5p to the 7. She says add 3 and 5, then add 2 and 7. Her answer is 8p to the 9. Oh, Lucy, Lucy, Lucy. Right, tick a box for each part of her method. Right, is adding 3 and 5 to correct? Should I add 3 and 5? No, no, no. You should be multiplying those two. It should be 3 times 5, giving you 15. So that bit, definitely wrong. Okay. What about adding 2 and 7? P to the 2 times p to the 7. Yes, that is correct. That should be p to the 2 plus 7. That should be p to the 9. So that bit was at least correct. She got half of it right. Okay, so the answer should be 15p to the 9. You'd think Lucy had given up by now, but no, she's boldly going on. Lucy thinks of a number. 10 times that number equals 10 divided by the number. Give possible values of the number. Okay. Well, when I don't know the number in maths, I like to use a bit of algebra. So 10 times the number, 10 times x, equals 10 divided by the number, 10 divided by x. I'm going to write that down as a as an equation. So 10 times x, 10x, is equal to 10 divided by x, 10 over x. Okay? So what can we do now? Well, we could multiply both sides by x to get rid of that x on the bottom. They cancel. And it'll leave you with 10x squared is equal to 10. Okay, and then we could divide both sides by 10. Okay, they cancel, and that's going to leave you with x squared is equal to 1. Okay, so give a possible value of x, well, we'd have to square root both sides then, wouldn't we? So the square root of x squared, the square root of 1, that is going to give me x is equal to, well, one solution is 1. You could actually have plus or minus 1, so, but it only asks me for a possible value, x equals 1. Okay, that would do, or x is minus 1, actually, that would also work. It doesn't really matter which one it is, they both give you the same answer and it only asks for 1. If for some strange reason you're not a fan of the algebra, you could do this one just by trial and improvement, just by picking some values and putting them in there until you got the right one. That would be a perfectly acceptable method here. It just might take you, well, it might be quicker actually. It's just I'm kind of a trained mathematician, I think, algebraically. And I'd love you to get to that place as well, where you are a trained mathematician who thinks algebraically. So anyway, either way is fine. Lily's age is 2 years and 4 months. Hugo's age is 1 year and 8 months. Write Lily's age in months as a fraction of Hugo's age in months. Give your fraction in its simplest form. Okay, so what we're going to do first is going to convert Lily's and Hugo's age into months only, aren't they, from years and months. So there are 12 months in 1 year. 1 year equals 12 months. So if I take the number of years and I multiply it by 12, I'll get the number of months. So then Lily, she 2 years and 4 months, that is going to be the same thing as 2 times 12 is 24 plus 4, that's 28 months. Okay, so she's 28 months old. Hugo is 1 year and 8 months. So Hugo, 1 year, 8 months. That is 1 lot of 12, which is 12 plus 8, which is 20. He's 20 months old. Okay, so write Lily's age in months as a fraction of Hugo's age in months. Okay, so Lily's age in months as a fraction of Hugo's age. That means Lily's goes at the top and Hugo's goes underneath. That might catch a few people out, because they might expect it to go the other way around. It's going to be a top-heavy fraction. Can I cancel that down? Yes, I can. 20 and 28 are both divisible by 4. So dividing top and bottom by 4, divide by 4, divide by 4. That is going to be, what's that, 7 over 5, 7 fifths. Doesn't really say whether or not I need to write it as a top-heavy fraction or a mixed number. I think top-heavy fractions are fine. I'd be quite happy to leave it like that. If you want to write it as a mixed number, it would be 1 and 2 fifths. But personally, I don't think that's any kind of neater than 7 over 5. Question 24. Working alone, it takes Kevin 4 hours to paint an area of 12 square meters. Kevin and Steve are going to paint an area of 24 square meters. Kevin said, working together at the same rate, it will take us 8 hours because 24 is 2 times 12. Is he correct? Tick a box, yes or no. I think he's wrong, isn't he? That's just wrong. If working alone, Kevin can do 12 square meters in 4 hours, then if he works twice as long, isn't he going to do twice as much? Okay, so on his own, he could do that in 8 hours. Presumably, if he's got a buddy along and his buddy works at the same rate as him, it's going to take them, they're going to do twice as much in the same amount of time. They should be able to do it, they should be able to do twice the work in the same amount of time, shouldn't they? So I think he's wrong. Give a reason for your answer. I'm going to say Kevin could paint 24 m squared himself in 8 hours. Okay, so he could do it himself in 8 hours. So with Steve's help, he should be able to do it in half the time. I'm probably writing far too much. You know, you look at the mark scheme and like one part of this would get you the marks probably. But anyway, let's be thorough, i.e. 4 hours. Okay, I've even said how long it's going to take, which is well overkill for 1 mark. But anyway, I just can't help myself. So 5x plus 6 is greater than 3x plus 14. So we've got a linear inequality here, unknowns on both sides. Now these solve just the same way as equations. So if that was an equals sign in the middle, would you know what to do? If you do, just do the same thing. I'm going to take the smaller number of x's away from both sides just to simplify first. So subtracting 3x from both sides to start with. This one is going to cancel with this one, and it's going to leave you on the left with 2x plus 6 is greater than 15. Okay, so we've simplified it quite a bit already. Next step, let's simplify that 6 there, subtracting 6 from both sides. They're going to cancel, and it's going to leave me with 2x on the left. That is greater than 15 minus 6. That's 9, isn't it? And then finally, dividing both sides by 2. Divide by 2, divide by 2. That's going to leave me with x on the left and 9 over 2. I'd be quite happy to leave it as 9 over 2. Like that, I think that's a perfectly acceptable answer. If you don't like that, you could write that as 4.5. But, you know, fractions are great. Mathematicians love fractions. So do examiners. Leave it as a fraction. B, write down the inequality represented by the number line. Okay, well, we're going to have one of those inequalities where you've got something in the middle and then 2 numbers either side of it. And those 2 numbers are going to be this number up here, look, 2, and this number over here, look, 5. So x is going to lie between 2 and 5. Now we need to work out exactly what symbols we need to have between those letters. Now notice that the circle is filled in above 2. That means that the x can be equal to 2. That is part of the inequality range. So x is going to be greater than or equal to 2. On the other end, 5 has got an open circle, okay, and that indicates that 5 isn't actually part of the inequality, so it can't be equal to 5, but it can be less than 5. So the answer is 2 is less than or equal to x, which is less than 5. That's the solution. The diagram shows an octagon. Yes, it does. It's an octagon on a pair of axes with some extra lines drawn on as well. So it's a little bit of a complicated diagram, isn't it? But you've got the axes down the middle. Here's the y-axis, here's the x-axis. You've got another couple of lines on there for good measure. And then you've got the octagon drawn on the axes like that. Okay, I'm just going to get rid of that to make it a little bit tidier. Now, x equals 1 and y equals 5 are lines of symmetry. Oh, so these are going to be lines of symmetry running through your shapes. That's a line of symmetry, and that is a line of symmetry running through the shape. Okay, work out the coordinates of the point Q. Okay, oh, we're going to have to work our way around the shape basically, aren't we? Okay, so now if x equals 1 is a line of symmetry, then this point over here, look, is the mirror image of P in that mirror line, isn't it? Okay, can you see that? So this line, x equals 1, is kind of like halfway. It cuts this line in half then if it's a line of symmetry. So this point here is the mirror of this point over here. So how far is it from P to the mirror line? Well, we need to look at the x coordinates here, don't we? So the x coordinate of P is minus 2. And then we're going to go over to x is equal to 1. So that is a distance of 3 units. It's 3 units from P to the mirror line. So that means the mirror line to our other point over there is also going to be 3 units. So it's going to be 3 units further along. Now the y-coordinate is going to stay the same because it hasn't moved up or down. It's in the same place as P. So the new coordinates is going to be 4, minus 6. Okay, so I took the fact that x equals 1 and I added 3 to get x is equal to 4. So that is the point 4 minus 6. Now if you have a look at Q all the way up here, then Q is going to be the mirror, the image point of that point I just found in the line y is equal to 5 now, because y equals 5 is the mirror line of this shape. So then Q is the reflection of 4 minus 6, isn't it? Okay, so again, how far is it from our point up to the mirror line? Okay, well, let's compare this time the y-coordinates. This has got a y-coordinate of minus 6, and this has got a y-coordinate of 5. So what's the distance between minus 6 and 5? That's 11, isn't it? That's 11 units. So it's 11 units from this point here up to the mirror line. Okay, so then if I want to go up to Q, it's going to be the same distance on the other side of the mirror line. So it's going to be another 11 units up to Q, isn't it? Okay, now the x-coordinate of Q is going to be the same as the x-coordinate of our middle point there that I haven't given a name to. I should probably give it a name. Seems a bit late now then. But anyway, that's going to be the coordinate 4, same as that one at the bottom. But the y-coordinate is going to be quite a lot more, isn't it? Okay, I've already gone from minus 6 up to 5 to get to the mirror line. I went up 11. Now I'm going to have to go up another 11 to get to the point Q. So if I add 11 on to y is equal to 5, I'm going to get up to y is equal to 16. Okay, so then the coordinates of Q are going to be 4, 16. Okay, I like that. That was fun. Work out 2,000 times 70,000. Okay, well, I've got the digits 2 and 7, and if I multiply 2 times 7, I'm going to get 14. But I've also got all these zeros on the end. 1, 2, 3, 4, 5, 6, 7. So I'm going to have 7 zeros after my 14. 1, 2, 3, 4, 5, 6, 7. So what's that? That's if I had commas there, that'd be thousands, and I've had another comma there, that's going to be millions. So that's 140 million. Okay, now what's that in standard form? Well, in standard form, I'm going to use the same digits, 1 and 4, and I'm going to put the decimal point in between them like that. So how far would the decimal point have had to move? It would have had to move 1, 2, 3, 4, 5, 6, 7, 8 jumps, wouldn't it, to get all the way over there? So that means this is 1.4 times 10 to the power of 8. Okay, that's my answer. 1.4 times 10 to the 8. Part B says work out 1.8 times 10 to the 2 divided by 3 times 10 to the minus 1. Okay, now these are two numbers in standard form that we're dividing by each other. Okay, now when you're dividing numbers in standard form, my advice is to divide the mantissa part, the number part at the front, by the number part, and divide the power of 10 part by the power of 10. Okay, so let's do the number part first. What is 1.8 divided by 3? 3's into 1.8, 3's into 1 don't go, carry the 1 over, 3 into 18 goes 6 times. So that's going to be 0.6. 0.6, if you think about it, 0.6, 0.6, and 0.6 adds up to 1.8, so it makes sense. Okay, so the mantissa part, if when I divide 1.8 by 3, I'm going to get 0.6. Now let's do the division of the powers of 10 next. Now I've got 10 to the 2, and I want to divide it by 10 to the minus 1. Now when we're dividing numbers with the same base, we simply subtract the indices, don't we? So it's going to be 2 minus negative 1. So it's going to be 10 to the power of 2 subtract negative 1. 2 subtract negative 1 is the same thing as 2 plus 1. So that is going to be 0.3 times 10 to the 2 plus 1. It's going to be 10 to the 3. Okay? Now it says give my answer as an ordinary number. So basically I'm going to be multiplying 0.6 times 10 to the 3, which is 1,000, isn't it? What's 0.6 times 1,000? That is 600. Okay, so my ordinary number is 600. That's my answer. A, B, C and D are junctions on a motorway. Now the distance CD is equal to 3 times the distance of AB. So this distance up here is going to be 3 times as big as this one. And the distance of BC, the bit in the middle, that we're told is 25 miles. Okay, so this one here is 25. If we say that this one here is X, then this one is going to be 3 times bigger. So then that would be 3x. Okay, so I've got x, 25, and 3x. Salma drives from A to C. Okay, so she's going from here up to here. Okay, she drives for 30 minutes at an average speed of 62 miles per hour. Work out the distance AD. Okay, so once we know, basically what we're going to have to do then is we're going to use this bit of the problem to find the distance from A to C, and then we can use that to find the distance from A to B, and once we know that, we can find the distance of C to D, and once we know that, we know everything. So it's going to be like a number of steps along the way here, isn't it? Okay, so let's start with, I think we're going to have to start with this. She drives for 30 minutes, an average speed of 62 miles an hour business. And I'm going to be using the DST triangle. Distance, speed, time. Distance, speed, time. So DST is alphabetical if you forget about what order they go in. So D first, then S, then T, as they are in the alphabet. And I want to work out what D is, S is, and T is. I'll know 2 of them, and I can use the 2 to find the 3rd one. Right, so she drives for 30 minutes at an average speed of 62 miles an hour. So we know speed, it's 62 miles per hour. And we know time. Now time is in minutes and speed is in miles per hour. So I'd like to convert that 30 minutes into hours so it matches the units with the miles per hour. So rather than writing the speed of a time of 30 minutes, I'm going to rewrite that in hours. So 30 minutes is half an hour, or 0.5 hours, isn't it? Okay, so time is 0.5 hours and speed is 62. So from that, we should be able to work out D, the distance. Okay, so we're going to cover up the thing that we don't know, it's the D. And then that tells us that the distance is equal to the speed times the time. Okay, so distance equals speed times by time, which in this case is 62 miles per hour times by 0.5. So basically we're going to halve 62, aren't we? And that is going to give us 31. What's the units? Speed was in miles per hour, time was in hours. Multiply it together, you're going to get miles. So that is 31 miles. Okay, so that whole pink bit up there is 31 miles. So if the green bit is 25, then that little equal yellow bit at the beginning must be 25 taken away from 31. So my little x that I wrote down there earlier, the little x down there is going to be 31, take away the 25, then that's going to be 6. Okay, so this is equal to 6 then. So 3x means it's going to be 3 lots of 6 there, and that's going to be 18 then, isn't it? So I've got a 6 mile section, a 25 mile section, and an 18 mile section. So what is the distance of AD? Then AD is going to be those 3 amounts added together then, isn't it? It's going to be the 6 for AB plus the 25 from BC plus the 18 from CD. And that adds up to, what's that, 31, 41, 49. That's 49 miles. Okay, that's my answer. Question 29, here is a sketch of a graph. Circle the equation of the graph. K is a constant. Okay, there's some of these that we can rule out straight away because they are equations of straight lines, aren't they? It's definitely not going to be this one. This is the form y equals mx plus c, isn't it? Y equals mx plus c. In this case, c is 0 and m is k. Okay, so it's a straight line. Similarly, y equals k plus x. That is the equation of a straight line with gradient 1 and intercept x. So that isn't it. Y equals k minus x. Again, that's the equation of a straight line. This time gradient minus 1, intercept k. It's not that one. The only one it can possibly be is this one here. It's the right hand side of a reciprocal curve, isn't it? That looks like this. Okay, normally you have it in two quadrants like this, and what we're seeing here is this bit up here. So that's the bit we've graphed. So it is it's y equals k over x. Write 200 as a product of its prime factors. Give your answer in index form. Okay, now if you've got the calculator paper, then you can just press it into, you can just tap it into the calculator and it will do this for you. But if you're on the non-calculator paper, you're going to have to do it the long way. I recommend using a factor tree. So you write your number in a circle at the top like this, and you think, what two numbers multiply together to give you 200? Now, there are lots of different options. You could go for 102, you could go 50 and 4, you could go for 25 and 8. It doesn't really matter which ones you pick. You always end up with the same roots anyway at the bottom. So I'm going to go for 50 and 4 just because 4 breaks into 2 and 2. Now they're both prime, so they're going to be stopping points. 50, I can make 50 out of 5 and 10. 5's prime, 10 isn't. I can carry on with 10. 10 breaks down into 2 and 5, which are both primes. Now all of my branches now are ending at prime, so I'm done. So then what I do is I say, well, all those numbers at the end, all those primes that are in the end, they're going to make up my number. So 200 then is going to be all those multiplied together. Now I've got 1, 2, 3 2s, so 2 times 2 times 2, and I've got 2 5s times 5 times 5. Okay, now this is what we call the expanded form, where all the factors are showing. If I want to write it in index form, which it asks for up here, I need to write these as powers. So then 2 cubed, rather than 2 times 2 times 2, I'm going to write 2 cubed, and rather than 5 times 5, I'm going to write 5 squared. Okay, so 2 cubed times 5 squared. Now you might want to just double check that that does actually give you what you want. 5 squared is 25, 2 cubed is 8, 8 lots of 25 is 200. I think that's good. Here is a right angled triangle. And I've got a right angle triangle. It's got an angle of 30 degrees and the longest side or hypotenuse of 10. And I've got a side marked by x. We're told to use trigonometry to work out the value of x. Now, this is a very straightforward, basic trigonometry question in right angle triangles. Okay, so it's a job for SOHCAHTOA. SOHCAHTOA, or whatever mnemonic you use in order to remember your trigonometric ratios. Okay, so what I'm going to do when I work with SOHCAHTOA, I kind of label each side of my triangle, hypotenuse, opposite, adjacent, so I can work out which ratio we're going to be using. Now I always start with the longest side, so that is h. Okay, so that is the 10 there, is the hypotenuse. Now the other two are worked out relative to the angle. Now this one next to the angle, joining on to the angle, is called the adjacent. And the one opposite the angle, which is that one down there, is going to be called the opposite. Okay. Now in this particular problem, we have been given the hypotenuse and we want the opposite. So we want the ratio that's got to do with opposite and hypotenuse. We don't want any of the ones with a in, so we don't want that one and we don't want that one. We want this one here. Okay. Right, so then writing out the ratio properly, sine theta equals op over hyp. Okay, so sine theta is op over hyp. Then we're going to sub in the values that we know into the equation. So sine theta, theta is the angle. So the angle, theta is there, look, 30 degrees. So it's sine 30 degrees equals. The opposite is the green one down there. That's my x. So that is going to be x. The hyp is the yellow one. That is 10. So that is x over 10. So I've got sine 30 equals x over 10. So if I want to find x, I need to cross multiply that 10 up to there. So it's going to become x equals 10 sine 30 degrees. And then we reach for our calculator. Oh no, I don't have it. So what we're going to do? Well, luckily, sine 30 is one of those angles that I know I have to learn for my GCSE, and I've memorized it. Have you? There's a whole bunch of angles that you need to know, and we call them the exact trigonometric values. So you should remember 0, 30, 45, 60, and 90 for all of sine, cosine, and tangent. If you have, you would recognize that sine 30 is the easy one. Sine 30 is just a half, isn't it, on 0.5. So now I know that sine 30 is 0.5, then I can find x, can't I? X is equal to 10 times 0.5, or half. Half of 10 is 5, isn't it? So x is equal to 5. Question 32, factorize x squared plus 7x plus 10. Okay, so when I'm factorizing a quadratic like this, I know it's quadratic because it's got an x squared term. I like to start with the number on the end, the 10, and I think about, well, what are the factor pairs of 10? Well, 1 and 10, 2 and 5, and that's it. Now, you should find that one of those factor pairs, if this factorizes, then one of those pairs should add up to the number in the middle, and I hope you can see that 2 plus 5 is going to give me 7 in the middle. Okay, so I think I'm going to get 2 brackets. I'm going to get x, and my two numbers multiply together to give you 10, and then they add together to give you 7. So those two numbers have to be 2 and 5. So I'm going to get x plus 2, x plus 5. Okay. Now, if you find these a little bit tricky, you could always then just kind of multiply it out again, just to satisfy yourself that it does actually give you x squared plus 7x plus 10. But I'm pretty confident I've got it right, so I'm just going to write the answer down. X plus 2, x plus 5. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides, and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.